Welcome toppers. So this is a now practice time 2 session in which we are taking the remaining question of the practice time 1 session. So let's start with the question number 51. So the question number 51 is a particle enters at the middle as shown in the figure with 10 to the power 5 meter per second will bend towards 1 ampere wire upward the plane of the wires towards 3 ampere, downwards the plane of the wire. So let us see the solution of this question. So this is a actually diagram of this particular question. So according to the right hand thumb rule, we know that magnetic field due to the left wire inside the paper and magnetic field due to the right side, and that is the point, like if I'm just taking the left side, so that will be inside from the right hand rule, and the other one is the outside. That means this will be look like this. I hope this will be visible. So this will be outward and this will be inward. So for that scenario, this wire will be towards 1 ampere wire. This will be, I hope you will be understanding what is the correct answer for that. Next, if I'm moving ahead with the next question. A conductor AB of length L carrying a current I is placed perpendicular to a long straight conductor XY carrying a current I as shown. The force on AB will be act Here is the option. This is the diagram. Along x to y, along y to x, to the right and to the left. The correct answer for this question, this is a theoretical question, so you can solve it. The correct answer is the 1, x to y. Moving ahead, the next question we have. A rectangular loop carrying current I is located near an infinite long straight conductor carrying current I as shown in the figure. The loop remains stationary. It is attracted towards the wire. It is repelled or will rotate an axis to the wire. This is a diagram of this question. So how to solve this particular problem if I'm just taking. So like if we just move towards the wire as the diagram is given, arm, if I'm just assuming this is an arm which is a BC arm. Okay, this is a BC, this is I'm assuming as a AD, ABCD, this is a arms. So if I'm assuming like a BC and AD, this is the equal and opposite. So the value of F1, that is the force, mu I, okay, this will be mu IL divided by 2 pi A. Similarly for F2, this will be mu naught IL divided by 2 pi A plus B. So if I'm just taking the correct answer for this question is it is attracted towards the wire. Okay, now if I'm just taking the next question. So next question we have two straight long conductor AOB and COD are perpendicular to each other and carrying current I1 and I2. The magnitude of magnetic induction at a point P at the distance A from the point O in the direction perpendicular to the plane ABCD. First, mu naught divided by 2 pi A I1 plus I2. This is the option. We have a lots of like a 4 option are here. You can choose any one of them. The correct answer will be 3. Moving ahead, two streams of electrons are moving parallel to each other in the same direction. They attracted each other, repel each other, cancel the electric field of each other, cancel the magnetic field of each other. The correct answer for this question is repel to each other. Moving ahead, we have a next question. Two parallel long wires carry current I1 and I2, where I1 is greater than I2. When the current are in the same direction, the magnetic induction at the point midway between two wires is X. If the direction of I2 is reversed, the magnetic induction becomes 2X. Then I1 by I2 is 1, 2, 3 and 4. So the correct answer will be 3. Next question, we have a light body is hanging at the lower end of a vertical spring. On passing current in the spring, the body rises up, goes down, no charge, oscillates up and down. The correct answer for this question is rises up. Next question, we have choose your correct statement. There will be no force experienced if two particle wire carrying current in the same direction. Two parallel wire carrying current in the opposite direction. A positive charge is projected between the poles pieces of a bar magnet. A positive charge is projected along the axis of a solenoid carrying current. The correct answer is the fourth one. Next question, we have two long straight horizontal parallel wire, one above the other, are separated by a distance 2a. If the wire carry equal current in the opposite direction, the magnitude of the magnetic induction in the plane of the wire at the distance a above the upper wire is mu naught I by 2 pi, mu naught I by 2 pi a plus mu naught I by 4 pi a, mu naught I by 2 pi a minus mu naught I by 4 pi a, mu naught I by 3 pi a. This is the correct answer. Next question, we have two parallel wires carrying current I and 2I in the same direction have a magnetic field B. At the midpoint between them, if current 2I is switched off, the magnetic field at that point will be. We have these options. So the correct option for this question is B. Moving ahead, a straight horizontal conductor of length L meter and mass m kg carrying current I ampere. The minimum magnetic induction which must exist in the region to balance its weight. We have these options. So, firstly, I just want to explain how this answer will become. So, we know the force acting on a current carrying wire is ILB or IBL. So the balance weight when ILB is equals to mg. That means we can say that B is equals to mg divided by IL. For this scenario, we can say the correct answer will be B by 2. Because here, as we can say that a straight horizontal conductor of a length L meter mass kg current I minimum magnetic induction when the things will be balanced. So the initial will be changed in the form of a B by. Next question, we have a conductor of length L carrying a current I produces a magnetic field of induction V1 around it. Conductor is kept in a uniform magnetic field of induction V2, which is directed normal to the length of the conductor. The force acting on the conductor is, this is an options. The correct answer for this question is B2IL for the second. Now the next question, we have an electron is launched with velocity in a uniform magnetic field B. The angle between B and vector B is 0 and 90 degrees. As a result, the electron follows a helix. Its velocity vector B returning to its initial value in the time interval of, we have these options. So the correct answer for this question is option second. Moving ahead, we have a next question. An electron and a proton each travel with equal speeds around circular orbit in the same uniform magnetic field as shown in the diagram. The field is into the page on the diagram. Because the electron is less massive than the proton, and because of electron is negatively charged also and proton is positively charged. So this is the diagram and we have these options. The first option which we have, like this is the diagram. So for this scenario, and the electron travels clockwise around the smaller circle and proton travels the clockwise around the larger circle. Next we have the electron travels counterclockwise around the smaller circuit and proton travels clockwise around the large circuit. The electron travels clockwise around the large circuit and proton travels counterclockwise around the smaller circuit. Next, we have the electrons travels counterclockwise around the larger circuit and the proton travels clockwise around the smaller circuit. So the correct answer will be second. Next, we have a question. The force acting on the charge Q moving with a velocity v in a magnetic field of induction B is given by. We have these options and the correct answer for this question is, you can pause the video and try to do yourself. So the correct answer for this question is option 3. Next question we have a proton and an electron enter a region with equal speed in which the magnetic field is suddenly switched on. The force experienced by them are, we have these options. Students, do pause this video, try to do yourself and just match your answer. So the correct answer for this question is option 1. So in this series, we have taken question 70 actually. So we have 3 questions remaining. Next question we have particles having positively charged occasionally comes with a high velocity from the sky towards the earth. On account of magnetic field of the earth, they would be deflected towards the, we have these options. The correct answer for this question is east. Next question we have, an electron and a proton enter a magnetic field at right angle to the field with the same kinetic energy. The correct statement, we have these. So, the correct answer for this question is option 2. An electron and a proton enter a magnetic field with equal velocity. The particles that experience more force is, we have these options. The correct option for this question is option 3. Last question we have, a charge Q is moving with a velocity v parallel to the magnetic field V. Force on charge due to magnetic field is. We have these options and the correct answer for this question is option 3. So right now we have taken only 70 questions. That means we have taken only 20 questions for this, for this session. In the next session, like practice time 3, we just try to complete like 150 questions. Like 1 to 50 we just cover in a one session. 51 to 70 we have a cover in the second. And the last we have just taken a long session for completing 150 question for this chapter. So I hope you like your question will be your answer will be matched with my answer. If there is any doubt, you can ask in the chat session. You can drop a question number in which you are facing problem. In the next session, if need, so I'll just draw the solution of each particular question. Till that, take care everyone. Thank you for watching this video.